Chatbots like Google Bard, GPT-3 and GPT-4 have taken the world by surprise because of their ability to generate pages of human-like text. All chatbots need intent for an acceptable quality conversation. Intents are general traits sometimes hidden in the user's message required for bot action. For example, the phrase "shall I put on a poncho for my 5K run today" will map to whether inquiry intent by its entire wording. TinyML solutions with text or audio inputs from mic USB are now able to detect intent in real time, which can help pick a different module of chatbots for an effective conversation. Did you know that by 2022, it's expected that chatbots will save businesses over $8 billion annually? This is because they are able to handle up to 80% of routine customer service inquiries, freeing up human customer service representatives to focus on more complex tasks. Intent classification plays a crucial role in ensuring that chatbots can accurately understand customer intent. In fact, studies have shown that implementing intent classification can improve chatbot accuracy by up to 98%, resulting in a 20% increase in customer satisfaction. AITS engineers have developed a low-code platform with templates to classify intent using TinyML and NLP techniques and machine learning algorithms. One way to implement intent classification using TinyML is through the use of LSTMs, or long short-term memory networks. In this TinyML solution, the text input is collected from a USB port connected to speech-to-text system and fed to a TinyML solution built on a body of texts and an intent label. In this POC, we've used an open-source dataset with 4 different labels including restaurant booking, play music, weather query and rate book, which can be enhanced to several hundred given the compute resource of the underlying inference system. With this dataset collected on a TinyML platform like cAInvas or www.tinyml.studio, it is easy to create a deep learning LSTM model to classify text intent in real time. A TinyML platform like cAInvas is used to train and test deep learning classifiers for intent classification. The model can be trained using various techniques such as long short-term memory networks with pre-trained deep learning models with an accuracy of over 98%. The deep learning model is easily created by connecting a TinyML device to a USB device collecting conversation text as input on a TinyML platform like cAInvas. The platform uses pre-processing that includes normalization and augmentation, and a quick training of the model resulting in an accurate TinyML model that is compiled with deepC for inference. The intent classification problem involves accurately identifying the underlying intent behind a user's message or query, despite the ambiguity and variability of natural language. TinyML provides a solution to the intent classification problem by enabling the implementation of machine learning models on microcontrollers and other small devices, making it possible to perform intent classification in real time, even in low-power environments. Consider using free sign-up to create your own TinyML intent classification application using Canvas Studio. Following notebooks and URLs are referred to in this video. Check the description for the links. Contact us.